So yesterday we discussed similar triangles. So these two triangles are similar by angle-angle similarity theorem. These two triangles are similar by side-side-side similarity theorem. And these two triangles are side angle side. So let's continue on with that discussion. We did. I'm just going over what we already did. All right, so yesterday we discovered that if we had this figure and we drew parallel lines that mimicked the figure, then we also saw alternate interior angles. Alternate interior angles are congruent, therefore I marked these two. Vertical angles are congruent, so I marked those two. And then we were able to write a similarity statement saying ABE is similar to CDE by angle-angle similarity theorem. Any questions on that? Okay. Why don't we put, I want you guys to look at this one and put this one in your clicker. Okay, so our answer is D. So let's figure out why the answer is D. So I have, now it doesn't tell me that I have parallel lines, but if I assume I have parallel lines, I can check later. So if I assume that these lines are parallel, I know you're not supposed to assume, but I did say I'm going to double check. And then I cut it by a transversal, that would make, oops, that would make this angle congruent with this angle. And if this were the transversal, that would make this angle congruent with that angle. Correct? And the vertical angles we know are congruent.
I just did, I saw the VOW was, and I saw I was, so I was on that.
Good. Okay, so I'm going to say that OBW is similar to TIW. All right, so this one says BOW, so that's BOW would be congruent or similar with ITW, and that's what that says, but we need to check. So OW is 7, so here's OW. BW is 9, BW is 9. WT is 17 and 5/10. WT is 17 and 5. WT, thank you. 17 and 5/10. And WI is 22 and 5/10. And based on this statement right here, I'm going to go back and say, all right, if I put, remember small, large. Small would be OW, which is 7, is congruent with, OW is congruent with TW. Here's TW, 17 and 5/10. Small on the other side would be 9. Should be similar to 22.5. And at this point, I would just take out my calculator and say 7 divided by 17.5 equals 4/10, and that should equal the same thing on the other side. 9 divided by 22 and 5/10, and it does. Okay? Is that clear? You just got to set it up and then check. All right, so get out your notes. I want you to draw this triangle, and while you're at it, let's draw one more triangle and be resourceful here. And I'm going to label it TSUVWS. How about that? Give you guys a second to do that. Okay, guys. Okay, so back to this. So reflexive. So who thinks that they can give me in a complete sentence if I were to say triangle, let's see how I wrote it. Triangle PQR is similar to what? Reflexive. Is similar to triangle PQR. are. Remember when we were proving triangles being congruent? Reflexive is the same thing. Okay, so that's that property. What about symmetric? If triangle PQR is similar to triangle TSU, then I can say, excellent, triangle TSU is also similar to triangle PQR. That's similarity with symmetric property. Who wants to do transitive? My favorite. You want to try it? Why? I'll start you off. If triangle PQR is similar to what? Good. Triangle TSU and triangle TSU, triangle VWX, then PQR is similar to triangle. Good job, guys. VWX. So this is saying that when we're using similarity, similarity is reflexive, symmetric, and transitive. Okay, is that clear? Can I go? 1 second. You got it, Desiree? Okay. All right, so go ahead and write down this drawing here, and then we'll talk about it. Okay, so let's begin by, it says right away that RS is parallel with UT. And I know that that is definitely a hint. You know what I'm going to do? I'm going to just copy these. Copy, paste. Copy, paste. So they look just like the other one. And then I'm going to draw a transversal here and copy paste it. Alright, so now it looks very, very similar, correct? And I know that alternate interior angles are congruent, so that one's congruent with that one. Therefore, is that right? No, that would be on this side. Undo, undo. This one is congruent with this one. That makes this one congruent with this one. And I don't need it, but that means that this one's congruent with this one's congruent with this one, and finally, we only need 2 angles though, correct? And vertical angles are always congruent. So right now we can already make a congruency statement, correct? So let's do that. Not congruency, I keep saying that, similar statement. So I'm going to start with what? R or S? S has got 1. Let's go in order. S, R, Q. S, R, Q is similar to triangle U, T, Q. U, T, Q. Everybody agree? Now, based on that, now I can use all this other information. I already know that, okay, let's do this too. Small, put this here, move this. Okay, so we're going to put small on top, large on bottom. I don't want to make that mistake again. So this small side should be proportional with this one. And this side should be proportional to this one. See, when you set it up nice and organized, it's not that hard. What should I be doing now before I start solving? I would simplify. Instead of this being 4, it's really 2 times 2. Instead of that being 10, it's 2 times 5. So let's simplify that, first of all. I'm just going to get rid of this. Yeah? We don't really need it. Okay, so now I've got 2/5 is equal to x plus 3 over 2x plus 10. Yes. Where can I take away the 10? No, because this is not 10. This is 2x plus 10. It's a quantity of something. Good question, Devin. All right, so now I'm going to cross multiply. So I get 5 times x minus 3, plus 3, is equivalent to 2 times 2x plus 10. Everybody with me?
Yeah.
Am I going too fast? 5x plus 15 equals 4x plus 20. Now, since I simplified, look what happens. When I solve for this, x is going to reveal itself from the very beginning. I won't have to divide. So that first step I took in the beginning, I saved myself a step at the end. See that? If I hadn't simplified, it would have been 2x equals 10, and I would have had to divide by 2. So I had to divide by 2 no matter what, right? Make sense? So since x equals 5, what did it want to know? What were we looking for? The original question, RQ and QT. Yep. RQ and QT. And RQ is at the top, what was it? X plus 3, thank you. RQ is x plus 3, and QT is 2x plus 10. So this is 8, and this is what? 20. Which should be a ratio. I'm going to show you. You don't have to do this, but this is smart. Because if you go through all this work on a test, shouldn't you make sure you're correct?
Yeah.
So I can do a quick check. Watch. RQ is the smaller one, right? And this is the larger. So it should be a proportion. I already have a scale factor. What's my scale factor? 4 over 10 or 2 over 5. Is it proportional? If I were to divide by 2 on both the numerator and the denominator, wouldn't that be 4/10? So it checks. And that took me about 15 seconds to make sure I was right. Right? Which is the difference between getting half credit for something or full credit. Because I always give partial credit for getting through it, but you could make a mistake somewhere and have the wrong answer. So why not on a test, go through it and make sure and check your work. And if you get the wrong answer, you don't go back and fix it. You go on to the next problem, right? And then you come back and fix it. Because that's the way you get the maximum points on a test. That's just me giving you some test-taking strategies. Okay, and then we're done.